Typically we think of summertime ozone as driven by photochemistry. The sunlight is making this chemistry from the sources. The wintertime ozone problem we think is driven by that plus a number of other things. It seems to require a snow on the ground, which tends to reflect sunlight and make the photochemistry more like summer-like conditions. It also tends to happen during really cold periods where the sources that are in that basin tend to get confined to a very narrow layer. The problem with ozone chemistry is it doesn't tell you where it came from. It's only formed in the atmosphere. It's not coming out of anybody's tailpipe or source. So in order to figure out what's making the ozone, you need a lot of other detailed measurements of oxides of nitrogen and those products and volatile organic compounds. Those are primarily emissions that come from oil and gas production. They come from tailpipes, trucks and cars, things like that.
Because it does get so cold, the air has a tendency to get very stagnant and stay close to the ground, what we call an inversion layer. You can look at it as a smaller box with all these emissions going into it. So ideally what we would have is a way to make the measurements from the surface, which is where all the emissions occur, all the way through the top of that inversion layer and up into the atmosphere above. Ideally, of course, we'd like to be at 100 meters, but a 100-meter walk-up tower would be just too much to deal with. So our way around that is to have another group from the University of Colorado bring a balloon that can have a payload of instrumentation on there that they can actually go up and down and sample the height of the atmosphere well through the inversion layer into the atmosphere above all the way to the surface. We're also going to have two other sets of measurements that are remote sensing measurements and get the horizontal distribution as well as the vertical distribution of these important molecules that contribute to ozone formation.
So behind me you see the mobile laboratory. That's a contraption of an old van where we now have a bunch of custom-made instruments. What we want to do is go and look at different sources that are emitting potential precursors of ozone in the oil and gas industry. So the mobile lab will be the connecting point between the different measurements that are going on at fixed sites. So while driving around, we can look at things more carefully and kind of differentiate between different sources. What is it that's emitting this particular molecule? And by doing this kind of detective work on the ground, on the road, around the whole basin, we can put the puzzle together.
My name is LeBaron. I'm the Deputy Director for the Utah Division of Air Quality, where I focus on air quality in the rural parts of the state, primarily the areas where we're having a lot of energy development. We're really looking to be very proactive in this study. These high ozone values aren't occurring year-round. They're occurring during specific episodes during the winter when we have snow-covered ground and a temperature inversion in place. But the values during those times can be very, very high. And so first and foremost, we want to protect the public and the environment. But we also recognize that the economy of the basin is energy dependent, and a lot of the jobs that people work out there are linked to oil and gas development. And air quality has the potential to affect those jobs. So it's really in everybody's best interest to understand how ozone's formed and work together to mitigate high ozone values in the future.
What we hope to do is really partner with the oil and gas people to target the right things. Because if you spend a lot of time and money controlling the wrong things, everybody loses. It costs money, it doesn't solve the problem. So what we're hoping to do is come up with a targeted set of recommendations of what to control the problem.